Yeah, they're horrible.
My favorite
Oh, yeah. That was a good one. I forgot about that one. No, I still think so. You got one. Okay.
I love shortbread. Thank you.
Okay, we're getting closer to start. Here, we pass this around. We have another basket going around. Sign sheets still going around? Around this side. Erik, are you ready? All right. All right, so I want to thank everybody for coming. It's the last MAC talk of the semester. We'll do it again in the spring, so please come back. I want to remind you guys that the MAC is open here for you to help as you move into finals, right? And I hope everybody registered this morning for their math and their science classes. So as our theme's been all year is Sherlock Holmes and the mysteries that he has solved. That's why we have some British snacks going around, right? Sherlock Holmes and Dr. Watson liked tea, and they liked little cakes, so the shortbreads, and they snacked on nuts and fruits. They said their favorite was plum. I couldn't find any plum cookies. I tried. Maybe next time. All right, so thank you all for coming. I'm going to turn it over to Dr. Goff. He's our fabulous chemistry teacher here on campus. Come on in, ladies. Go along the side there. Because everybody needs a science class, right? Whether it's chemistry or biology or both, if you're lucky and you get both, right? We get to enjoy you in math and statistics, and so one of our things is we bring in the other sciences and other things on campus so you can see where math is used in other areas. It's just not because we told you so, right? All right, thank you, Randy.
All right, you're welcome. Well, I'm going to tell you, I'm a casual fan of Sherlock. I probably read more Sherlock than I've ever had in my life prepping for this talk. So I'm sure there are probably a lot of you that are well versed in Sherlock more than I am. But one of the things I did know about Sherlock Holmes is he's an avid chemist, or at least an amateur chemist. And just about every Sherlock Holmes story has some aspect of chemistry involved. And maybe we'll talk a little bit about why that is. So we probably know pretty much, who Sherlock is. Maybe not as much about Dr. John Watson. He's actually a medical doctor. In the stories, he served in a war in Afghanistan and ended up meeting Sherlock Holmes through a mutual acquaintance. But we know that these stories, there's several stories, but there's only 4 novels. I was really surprised to know that Arthur Conan Doyle wrote. Most of the stories are very short stories that were written over a 40-year period. But Sherlock is a self-proclaimed, the world's greatest consulting detective. And I guess it's thrown in there because he didn't really work for Sherlock or Scotland Yard. He was a freelancer. He did his own thing. But he used forensic science. He used a lot of chemistry to help solve crimes. And so you could see chemistry pops up in all these stories in a lot of different places. And this is my most favorite depiction of Sherlock. I like the Benedict Cumberbatch version of Sherlock Holmes. You probably have your own favorite. If you know what this is from, then that's great. But what we're going to talk about today, because there's so much chemistry involved, I've narrowed it down to 4 interesting compounds, or what I thought were interesting, or applications that were interesting. And we're actually going to involve math in this, because those of you who've taken one of my chemistry courses know that there's a lot of math involved in chemistry. So we'll be doing some math here. So if you've got a calculator, you might want to get it out, because we'll be doing a few calculations, but not a lot of heavy lifting. Okay. So the first published story, or rather novel, of Sherlock Holmes was A Study in Scarlet. That was published in 1887. And this was kind of an interesting adventure. We get to know who Sherlock is. He's got all these quirks that are enumerated, but he's described as being a first-class chemist. Okay. And kind of what's interesting is John Watson is a narrator, if not all the stories, but for most of the stories. And so we hear his description about who Sherlock Holmes is through his, narrating the story. And definitely a lot of interesting things going on, maybe sensational literature. Maybe that was sort of the Real Housewives of London at the time or whatever. But you've got poisons in there and you've got chemistry, and we're going to see a little bit of both of those. So Sherlock Holmes is actually a technician in a medical lab in a hospital in London when the story starts. And so he's not just, lounging around his apartment and all the stories. He actually does have a job. And the first story that we find out, in this story, we find out something called the Guiacum test. Now, what happens in this story is John Watson comes back from Afghanistan. He's been injured in the war. He needs a place to stay to recuperate. Sherlock Holmes needs a companion, and he's got maybe some money problems. He needs a roommate to help pay for the rent. And so there's a mutual acquaintance that brings these two together. So in the story, John Watson is brought to see Sherlock Holmes in his place of work in this medical lab. And he starts immediately, kind of just seems like he grabs Watson and just says, hey, come over here and check this out. This is really neat, right? And he starts talking about something called the Guiacum test. And this is a test that's actually used today. But the Guiacum test is a means of identifying minute amounts of blood that you might have in a sample. Maybe a sample you might find in a crime scene. Maybe it's in some kind of a biological sample. Okay? And so the Guiacum test comes from a compound called the guaiaconic acid. I'll show you a graphic here in just a minute. And this comes from a resin in the guaiacum tree. And this resin is sensitive to certain catalysts. And it will react with something like hydrogen peroxide. And when it reacts with a catalyst like hydrogen peroxide, it'll produce this really neat blue vivid color. Okay. So here's an example of this. Now this is a test that's actually done today. It's called a fecal occult blood test. And the name is exactly what it sounds like. It's used to detect very small amounts of blood in stool. And it's a diagnostic test that might be used to check for colon cancer because we're not supposed to have that in normal stool. So this is actually used today, and it was interesting that this current test was talked about, over 100 years ago. So what happens is you've got this molecule, so it's depicted here, and when it's introduced to a catalyst, so those of you who've taken biology might be familiar with an enzyme called a peroxidase that acts as a catalyst. It's an enzyme. But also in blood, we have something called hemoglobin, and an important part of hemoglobin is heme. Does anyone know what heme does? What the function of heme is in blood? Any biologists here want to share? They know about heme?
Carry oxygen.
It carries oxygen, right? And so there's an iron molecule in there, and that will oxidize this up to this form of this acid, and it changes its structure so that it's able to emit blue light, or it absorbs light and it emits blue light, and that's what we're seeing here is this vivid blue color from this test. Well, what was really interesting in this story is Arthur Conan Doyle, through Sherlock Holmes, because remember, Sherlock Holmes isn't a real person, right? Everyone knew that, right? Okay, it was a character? Okay. Yeah. So Arthur Conan Doyle recognizes the importance of the scientific method. Now, during this time, this test wasn't the most reliable, and a lot of it had to do with the British diet. There was a lot of red meat, a lot of wine, a lot of foods that if you didn't abstain from when you needed to take the Guiacum test, you would get a false positive, and some of your diet, what you ate, might look like there might be blood that's present. And so Arthur Conan Doyle in the story writes for Sherlock Holmes this test, and here there's some text from the story, that he develops this test, and it's a fictional test. He doesn't really go into detail about what's actually happening. but he explains this to Watson, who he's just met, that he's able to detect very, very minute amounts of blood in a large amount of water. And so it's kind of his way of saying, hey, this is what we currently have. It doesn't work too great. Let's develop a method where we don't have these issues that we would want to avoid. Okay. So it was really interesting that over 100 years ago, we had this bit of popular fiction where the use of the scientific method was being given to the public and shown why it's so important. Now today, we use luminol to detect blood. And luminol is very sensitive. It can detect amounts 9 times 10 to the negative 5th percent by weight. So meaning that if you had 100 parts of stuff, less than 1 part of that could be detected, a very, very small amount. So here's the math part. Okay, so if you want to get your calculator out, we're going to start really easy. If you convert from percent to parts per million, now percent is parts out of how many? 100, right? So parts per million is out of 1,000,000, and so we use parts per million if we deal with very small amounts, even smaller than something, a fraction of a percent. So if you take that, multiply it by 10,000, what do we get in parts per millions? Anyone have that? So 9 times 10 to the negative 5th, yeah, what do we get?
Is that 1?
A little bit smaller than 1. We get 0.9. So we get 0.9 parts per million. So we're talking about if you had 1,000,000 parts of stuff, and less than 1 of those was from blood, luminol could detect that. So it's a very sensitive method for blood detection. So that's what we use today. Wickham test, we still use that today. It was introduced around the time of Sherlock Holmes. Okay, so let's move on to another interesting topic. We're going to talk about a poison. Lots of poisons in the Sherlock Holmes stories. I'd never heard of this story. It's The Adventures of the Devil's Foot. And this is the source of a really interesting poison. It's a fictitious poison, but it's based in reality. So in this story, you had a group of people, a lot of them, this was a family, adult siblings, and they got together, and whatever English people did in the late 19th century in their flat in the evening, that's what they were doing. The next day, someone shows up and finds that there's a sister that's dead and these 2 brothers, and they've gone insane. And then they find out that the next day, one of the brothers has died. So Sherlock Holmes and Watson are brought in to solve this crime, to figure out, what killed these people, and more importantly, who killed these people. But Watson, or rather Sherlock, finds that there's a residue in the fireplace and a residue in their lamp. And this residue, he comes to the conclusion, must have been activated. There must have been a poison that was activated through combustion, and that vaporized it. They breathed it in, and it caused them, to die or to be paralyzed in some way. And they eventually find the source of this poison, and it's a fictitious plant called the devil's foot root. And they find someone in the story that had traveled to Africa, and they had brought back samples of this root. Well, the background of this, even though this is fictitious, is pretty interesting. Right around this time, Britain, or England, I should say, they're kind of at the apex of their empire, right? They have territories in Africa, they've got colonies in Asia, and their biggest colony is probably India, okay? And around this time, they've got all of these different things being collected all over the world, coming back to England for study. And you've got anthropologists that are really interested in the cultures of the people that they come across. You've got toxicologists, you've got pharmacists. They're looking at all of these plants that are being brought back. Zoologists looking at all of the animals that are brought back. And so there's this large amount of excitement going on in England about all of these really neat things that are exotic. They're not endemic to Europe. They're coming back, and they're being exposed to all of these things. So there was a great excitement about these really interesting compounds. And so there was a book published 3 years after a study in scarlet called the Pharmacographia Indica, And it's a description of what are called vegetable drugs. In other words, these are compounds that came from some kind of a plant source. Okay. And in this book is an interesting compound or interesting plant called aconite. And if those of you that are fans of Harry Potter, aconite is also known as, this is the part where Snape is kind of lecturing the class at one of the movies. He calls it monk's hood or wolf's bane, and Harry's writing everything down, and Snape's going to get on him because he's not paying attention to him. And in this story, or not the Harry Potter story, but in this story, you've got a root, and this root has a poison in it. Now, this is a fictitious root, but in actuality, there's a root called aconite, and it kind of looks like a deer's hoof or deer's horn is how they describe it, and there's the flowering part of the plant. And it turns out that this plant contains a compound called aconitine, which is actually a series of these molecules. And it turns out that these molecules have a very curious property that causes paralysis. And having cardiac paralysis is probably not a good thing. What do you think that means if you have cardiac paralysis? Yeah, your heart stopped. Probably not a good thing. They probably want to avoid that, right? And so taking aconitine would cause paralysis, and one of those could be stopping your heart. And so in this story, what it's believed is that Arthur Conan Doyle takes something from actuality, this aconite that was discovered, turns it into something a little bit different, kind of a plot device, makes it his own, and he calls this the devil's foot root. Kind of sounds a little bit cooler than just, monk's hood or wolfbane or something like that. But what's interesting about this is it has a scent that smells like Harasium or castor. And these are actually compounds that we might find in perfume or cologne. They form the base of perfume and cologne. Okay? And these actually come from animals. All right. So yeah, there are a lot of really interesting, come on, we're going to advance here. So one of the things that's kind of interesting about these molecules for chemists is that we treat these complex molecules kind of like Mount Everest for a mountain climber, right? Why did, maybe it wasn't Sir Edmund Hillary, but any of those of you that are into mountain climbing or rock climbing, why do you do it? Why do you climb the mountain?
Because you can.
Because it's there, right? Because you want to climb it. So for chemists, like we have a kind of a satisfaction of, hey, I want to build this molecule. So you can get the molecule, you can extract it from a plant, which can be kind of easy, or you can build the molecule from scratch, which is really, really challenging. So about a dozen years ago, it wasn't just two chemists, but these are the two main chemists that reported this paper. They took simple molecules and in 53 steps created an analog of aconitine, okay? And 53 steps is a lot of steps, okay? 1 step, 2 steps, we do that in our chem labs here, but 53 sequential steps takes months and years to accomplish. And so the challenge is, with so many steps, is you want to maximize how much you get out from each reaction, okay? Because in every reaction, you're going to have some diminishing returns. It's sort of like the gasoline in your tank in your car. Not all the gasoline is going to use to power your car. You're going to have some friction. You're going to lose some energy to heat. And so your engine's not going to be 100% efficient. Just like that with chemistry, not everything is 100% efficient. So in every reaction, you're going to lose just a little bit, okay? So just imagine 1 step you lose a little bit. Okay, 2 steps, okay, 53 steps. So let's see the effect of losing a little bit every step for 53 steps. Okay, so in chemistry, we have something called a percent yield, which means like how much did you get out? 100% means you got out as much as you could get. 0% means it just didn't work, you didn't get anything. Now let's say that everything worked great and we got a 95% yield out of every step. And that would be amazing. Any chemist would love to have anything like that, okay? So to figure that out, you would take every step's percentage and multiply it by the subsequent steps. So if we're assuming all of these are 95%, then we can take it to the 53rd power. And let's say we start with 10 grams, okay? So 10, I promise I won't mess up your puzzle. So 10 puzzle pieces worth, okay? Not a lot. So what do we get if we take 10 and multiply that by 0.95 to the 53rd power? Does anyone want to do that? I see Kaylee's on her phone. Maybe she's doing that. Yeah, what did you get?
0.4849452525.
Oh,
No?
I got something different.
0.6597.
Yes, okay. You get 660 milligrams, so less than a gram. And that's if everything works like super well. Okay? So out of 10 grams, out of 10 puzzle pieces, we get less than one puzzle piece at the end. It doesn't sound like a whole lot. Okay? Now, this is not a realistic number. You're not going to get anywhere near that. Something still not quite realistic, but a little bit more in reality might be 67%. Okay? All right, math people and the rest of us, okay? Try that out, and what number do we get if you change it from 95% to 67%? Remember, you're doing this over 53 steps. What do you get? This is crazy, yeah.
6 to the negative 9 grams.
Yes, we get 6 nanograms, like a billionth of a gram. Like that's like nothing, right? So one of the things that chemists we have to be aware of is sometimes you have to do things multiple times because of the diminishing returns is going to have such an impact. So this is not a trivial process. And so this is why so many important compounds come directly from nature instead of us trying to create them in the lab. Like, we want to make it because we learn things from making molecules. But realistically, it's a lot easier pulling things from the plants themselves. Nature does a much better job than we can do because nature's very efficient. Okay? I told you this would be fun, right? This is a good use of, instead of eating lunch, right, coming to hear about this. Now, I had never heard of this next story. Guess what it's about?
An engineer's thumb.
It's about an engineer's thumb, right? Okay. And this is actually an application of a beneficial matter for chemistry. So in this story, we've got an engineer. He's hired by some individuals, kind of shady people. He gets called out somewhere in the outskirts of London, and he goes to some kind of abandoned-looking warehouse. And he's hired to fix a hydraulic press. And the people that are hiring him tell him, well, you know, we're making bricks. And we need this press to make these bricks, but the press is broken, so could you fix it? And he looks at the press and says, hey, this is a lot more, than you need to make bricks. You could use something a lot simpler to make your bricks. So he starts asking questions, and he finds out, well, these people are counterfeiters, and they're really making coins from this, because this is really before the advent of paper money became big. So they're actually making like guineas or crowns or whatever crazy British currency they have. And so he gets chased away, or not chased away, but they're going to get him down because he's going to go tell the authorities. And in the chase, guess what happens? Yeah, he loses his thumb. Okay, so he jumps out the window, and in the process, I don't know if the guy whacks his thumb off or he just loses his thumb, but his thumb comes off at some point. He passes out, and some good Samaritans find him, and they know Dr. Watson, so they drag him to Watson to instead of the hospital for some reason. And he gets treated by Dr. Watson. And then in their apartment, Sherlock Holmes hears the story, and he starts to kind of fit pieces together to figure out who these people are. Well, he talks about using something called a carbolized bandage to wrap up his injured hand. And carbolized means carbolic acid, which today we know as a compound called phenol. And phenol was extracted from coal tar during Arthur Conan Doyle's time, since there was a lot of coal being used to power industry. But during this time, surgery was becoming more and more routine, but also was more and more routine was infection because you had surgery. And so it was more likely you were going to die from the infection of the surgery than maybe the effects of the surgery. So Joseph Lister, who was a little bit before Arthur Conan Doyle's time, had pioneered the use of antiseptics to avoid infections before and after surgery. And so phenol was one of these substances that Joseph Lister had mentioned in some of his writings. Now, we still use this today in various ways as a topical anesthetic. You might find it in some sore throat lozenges and some other things as well. But the chemistry aspect of this is kind of interesting. Phenol is a weak acid, right? And is there anybody in here, maybe a student, that knows what a weak acid is? No? Okay, so weak acids are acids that they don't let go of their hydrogen ion very readily. They kind of hang on to it a little bit. And so phenol, when you put it in water, doesn't really like to let go of that hydrogen very well. And so the value that we use to describe the strength of phenol is something called the acid ionization constant, or we just call it Ka. And the larger the Ka, the stronger the acid. But oftentimes in chemistry, especially organic chemistry, because we've got a hydrocarbon molecule, we want to use something called a pKa. And math people, pKa is like pH. It deals with a logarithmic function. So if you take the negative log of your Ka, you'll come up with the pKa. So I bet you guys could do this in your head. If you took the log of that number, what would you get? And then just take the negative of it. It would be 10, right? Okay. So the pKa would be 10. So by itself, 10 probably doesn't have a lot of meaning. But here are 3 acids that are commonly found in our homes, right? Does anyone know where you typically find acetic acid in your home? Vinegar, right? Okay. What about sulfuric acid? You probably have some in your car. Under the hood of your car in a battery, okay. And then muriatic acid is actually hydrochloric acid, but it's diluted down, so you might find that in your swimming pool chemicals, okay. So these are 3 acids, and they have Ka values, okay. So if we do the negative log of these, we can get the pKa's, okay. And muriatic acid, or hydrochloric acid, I should say, is the stronger of the 3. It has the lower pKa value. So we use this quite a bit in chemistry to compare strengths of acids. Okay. So a use of chemistry in a Sherlock Holmes story that didn't kill anybody. That actually saved someone. Okay. Now the last one, I saved the best for last. Now I passed this around at the beginning. I had some chocolates in here. Chocolate has theobromine in it, and this is an alkaloid compound that's found from, well, alkaloid is something you find from plants. And this is kind of like the feel-good stuff that you get from chocolate, kind of makes you feel good. And this is actually in a few of the Sherlock Holmes stories. And we're going to talk about another feel-good molecule that's in a lot of Sherlock Holmes stories. Can anyone think of a feel-good molecule that Sherlock Holmes is kind of known to be associated with? Cocaine or opioids, okay, or morphine, right? And so in the sign of the 4, okay, I didn't write this, this comes directly from the story, okay? So he offers, what's it today? So the I here is Watson. He's like, what are you taking today, buddy? And he's like, well, just a 7% solution. You want some, okay? So there's a lot of drug use in Sherlock Holmes stories. And what's really interesting is that during this time, drug use was kind of rampant, and it was actually a very fashionable thing. And Sherlock Holmes was described as a man who took cocaine before cocaine was fashionable. I guess at one point that was sort of like the hip thing to do in Victorian era England. And the big question is why does Arthur Conan Doyle write Sherlock Holmes as a drug addict? Well, actually, you can see how things evolved during this 40-year span, where at the beginning it was a very fashionable thing, but toward the end of these stories, in the beginning of the 20th century, he kind of weaned Sherlock off the drugs because it was starting to known that these compounds were detrimental. So why is he written as a narcotics user? Well, again, medicine, drugs, these were new things. they became more widespread. So it was kind of like their version of what's the next fad, like what's the next app, like TikTok or whatever it is. And so this is, I guess, their version of TikTok, which is kind of sad. So, Arthur Conan Doyle, he was a physician. He would have known about cocaine and how it could be used. Being a doctor, he recognized that it had positive medicinal properties. It could be used as an anesthetic in minor surgery without knocking out the patient. And that's actually a good thing, because if during this time you knocked a patient out, there was a chance they wouldn't wake back up. So if you could kept them lucid or awake during this time without having pain, that was actually a good thing. Today, does anyone know how cocaine is used medicinally, like one application? Eye drops. So when you go to the doctor and you might have eye surgery, they might use eye drops to perform some procedure without having you to feel that. And I think the old LASIK procedure radial keratotomy before LASIK procedure, I know that they used that. But during this time, there was no drug control. There was no legislation about drugs in Victorian era England. It was just like, wow, there's this really cool stuff that will keep you awake for a while. Okay, so it was a fashionable thing to do. It was so fashionable that it was actually given to kids. It was known to be an additive to cough drops. And this is my favorite, Mrs. Winslow's Soothing Syrup. And you can't read this. It's also called the mother's friend. So you could just imagine how that was given. Okay. But one of the reasons that Sherlock Holmes gives for taking cocaine is that he just was bored between cases. He wanted to stimulate his mind. And I guess Arthur Conan Doyle's way of having him not just be bored all the time was to, get it going. So it provided an outlet and some kind of a mental stimulation for him. There's 8 distinct stories that describe its use, including ones toward later in the story sequence where he's getting weaned off of that. But I want to give you the opportunity to, let's just say, be acquainted with cocaine, but in a very addictive sense. So I've built the cocaine molecule from a model set. So now tonight, when your mom asks you, what'd you do in school today? You could say, well, we played with cocaine. So, but in a very legal way, non-illegal way, okay? So all biological compounds have an active dosage or a useful dosage, like cocaine, which comes from the coca plant. And when you use a compound that's biologically active above its dosage recommendations, then you run the risk of having side effects, which can include death. And so cocaine might be used in many different applications. You might steep it like you'd steep tea. Here's a large-scale application. This is not a picture I took. I just grabbed this off the internet. But all biologically active molecules have something called an LD50, and that stands for lethal dose that will kill off 50% of the tested population. So even cocaine has an LD50, but it would be really unethical to treat people with cocaine to find out how much would be needed to kill half the people off. I don't think that would pass an IRB. Is that right, Josh? Probably not. Josh says no. That wouldn't be kosher. Now, the lower the LD50 value, that means the higher the toxicity, so the less you need to take to kill you or kill 50% of the population. There's the structure of cocaine there. Okay. Now, it has been studied in mice, so I guess ethically it's okay to dope up mice, just not people. But one study has found, and I think this was back in the 80s when I guess there was a lot of cocaine around, so I hear. The LD50 was cited as being, for every kilogram of body mass for mice, 95 milligrams would be enough to kill half of that population. So I thought it would be fun today to find out how much it would take to kill half of the class here off. So if you take your weight in pounds, most of us know our weight in pounds, and we convert it to kilograms, and use our conversion factor from kilograms of body mass to milligrams of cocaine, we can figure out how much it would take to kill off half the population. So I would invite you, if you've got a calculator, you don't have to tell us your weight, go ahead and punch that in. I'm going to do the same, and we'll find out how much will it take to kill Dr. Goff here. Okay, well, that's an interesting thing. I don't know if I could get that much up my nose. I'd probably have to find another way. Probably would have to go up somewhere else. Okay, all right. Okay. What? 6 grams, okay. Some of you will probably be a lot less. Some of you would probably be a lot more. So again, your mileage might vary. This is all based off of statistics, right, Kaylee? Yeah. So it's not just this is going to kill every person, but this is just statistically based off of a whole population. Okay. So kind of my final thing I want to leave with you is, you know, what really makes Sherlock kind of this endearing character, these stories last so long? There's actually a story, a TV show on TV right now, a current TV show that focuses on Watson as a doctor in a hospital. So these stories have been around for so long. You know, what lets them kind of live on in our popular culture? Well, you know, he's a really quirky guy. A lot of us, you know, or if not all of us, have some kind of quirks, like we're all kind of drawn to science or math or some other field that would be considered kind of, you know, nerdy. But we all kind of have something that makes us different, and Sherlock's definitely a different person. But I think it's a very accessible story. And really, what I hope that you get from the classes you take at Western, not just in STEM, but any class you take, is that you find that the subject is accessible, that it's actually something that you don't have to be in an ivory tower to understand. Like, this is something that we want the general public to be accessible and to understand. So thank you much for your time and for your attention and for coming today.
That was fantastic. Thank you. All right, so